So what you have in front of you is your assignment on gravitation. So this covers the second half of the unit. All right, so it's going to cover Newton's universal law of gravitation, satellite motion, and gravitational field strength. Okay, that's the only three things that are on there, right? So the questions are all pretty straightforward. Number 10 is probably the one that's most involved. It's actually not that mathematically difficult, but it's just got a lot of like fiddling around that has to be done on it. Okay. So just make sure, guys, as always, that you read the question carefully. Look at how many marks it's out of, okay, so you can determine how much work you should be doing, because some of them are pretty simple. Some of them are just, you're plugging numbers into Newton's universal law of gravitation, okay, and you're done. So don't overthink them, okay? Also remember your significant figures. Okay, be on the lookout for tricky numbers, okay, and things like that. So just a couple of things here, guys, about the questions. Obviously, number one, there's not much to tell you. Okay, you're just looking for the force of gravity between Jupiter and the sun. Okay, for question number two, they've given you some information about Uranus and asked you to find Uranus's orbital radius. There may be more than one way to do that one. Okay, question number three, they're giving you some information about Venus, and they're looking for the orbital speed of Venus. There may be more than one way to do that one. Question number four is asking about Cavendish's torsion balance that we talked about in class that one day. Okay, so they're giving you information about the big lead ball and the small pith ball, okay, and how far apart their centers are, looking for the force of attraction between them. Remember, Cavendish is the one who made Newton's universal law of gravitation work, so this is probably a universal law of gravitation question. Okay, number five, same thing, but there's a trick to number five. Okay, electrons are all what? Are electrons all the same? They are. Electrons are all the same. Keep that in mind for question number five. Okay. Electrons are identical. Okay. Number six is asking about a moon of Saturn, giving you an orbital radius and an orbital period. You're looking for the mass of Saturn there. Okay. So maybe like satellite stuff. Okay. Number seven is definitely satellite stuff, but look at the units they're asking for. Make sure you give the right units for the period of the orbit of Apollo 2. Okay. And you're looking for the velocity of travel, that as well. Okay. Number eight. Spy satellite would seem to indicate it's probably a satellite question. Okay, there's probably only one way to do that one though, because I want you to consider something. It's a spy satellite. There's really only one place we need to spy on. So when you're considering where this satellite is likely orbiting, it's probably orbiting Earth, as we don't need to spy on anyone else. Okay. And then for number nine, we did number nine, yes, the other day, but not as we did it as a Kepler question. Okay, whereas number nine is probably more of a satellite motion question. Number 10. Here's what I will tell you about number 10. It's net force and it involves vectors. Okay? The only force in that question is gravity. Right? There are no other forces that are attracting those four objects to each other. Right? The force of gravity between them is the only thing. So you've got some vector addition stuff to do on that question, but it's not overly difficult vector addition. Everything's 90 degrees essentially, or 45 degrees. Now, the other thing I need to point out to you, they give you the dimensions of the diagram here. Okay, so from this mass to this mass is 1 meter. Okay, from this mass to this mass is 1 meter. This mass to this mass, 1 meter. This mass to this mass is 1 meter. How far is it from this mass to this mass? Yeah, it's not 1 meter. I don't know how many times I see people do that when they're trying to figure out how far away mass 1 and mass 3 are, and they tell me that a square that's 1 meter on all sides is only 1 meter across diagonally. No, it's a little further than that. Okay, you're going to need to calculate the right distance if you want to get that question right. Okay. 11, satellite motion question. Okay, 12 also is actually gravitational field strength, and number 13, okay, you're looking for a gravitational force there. Okay, so force of gravity question. Okay, you'll find that a lot of those go really quickly. There's only a couple of questions that are really going to gobble up your time. Okay. All right, if there's no questions, have at her.